Hello students, welcome to my channel. Today we are here to discuss about electricity and magnetism. If you remember, last time we had discussed about geometric optics. This time we are going to discuss about electricity and magnetism, which is another branch of physics, where electricity and magnetism both are the phenomena which are related to each other, and together they produce electromagnetic force. And the study of electricity and magnetism together is called electromagnetism. But we will discuss about that later while finishing the syllabus and dealing with different chapters of the syllabus. But today let us discuss first about electricity. What is electricity? We all know our lives are not possible to be comfortable without the help of electricity. We use electricity for lighting, heating, cooling, and refrigeration, and for operating different appliances like computers, electronics, machinery, and public transportation systems, and so many other areas where we cannot think our lives to be normal without the help of electricity. But the question is, how to produce electricity? How is electricity produced? Electricity production can be understood with the help of a simple circuit where we require things like wires, bulbs, switch, and cells. Dear children, you can see in the diagram, which is a circuit diagram, that there is a battery. As I told you, battery is a collection of two or more cells. One terminal is positive and another terminal is negative. From the positive terminal, you can see a red wire going and getting connected to the bulb, and the negative terminal of the battery is also connected to a wire which goes to the switch, and then from the switch the black wire goes to the bulb. The switch here is open and disconnected, and the circuit is not complete. So the current is not flowing through the wires. The electricity is not flowing through the wires. You can see in the following diagram also that there is a bulb, a battery, and a switch. No current is flowing because the switch is in the open position. You can see in the following diagram that this is the diagram of a closed circuit where the switch is in the on position and the circuit gets completed, because of which the electricity starts flowing, the current starts flowing into the wires. As soon as the switch, as shown in the diagram and the picture, is put on, the current starts flowing and the bulb starts flowing. But what is the magic behind this? The magic is the flow of current is due to the flow of charge. The charge starts flowing and this produces the electric current, thereby producing the electricity. The charge starts flowing from the positive to the negative terminal of the battery. But does the current really flow from the positive to the negative terminal? Is this the right direction? But the flow from the positive to the negative terminal of the battery is known as the conventional current. Because electricity was discovered much earlier than the flow of the charge, because charge is nothing but the flow of electrons. And afterwards, it was discovered that the flow of the current is due to the flow of the electrons. And what is the direction of the electrons? The direction of the electrons is from the negative to the positive terminal of the battery. That is the real direction of the flow of current. But as a symbol, we always talk of the conventional current. That is, the current flows from the positive to the negative direction, although the reality is that the real current flows from the negative to the positive terminal of the battery, that is in the direction of the flow of the electrons, that is in the direction of the movement of the electrons. So, the movement of electron is the movement of charge. The flow of charge results in the production of electric current, and hence it helps the bulb to glow as soon as the circuit gets completed. Know that every substance is made up of small particles called the atoms. You can see in the picture here that atom consists of the protons, which are positively charged particles, the electrons, that are negatively charged particles, and the neutrons, which have no charge. So number of protons is equal to the number of electrons in any atom. But there are certain substances which have valence electrons in the outer shell. And as soon as the valence electrons start moving, they produce electric charge. The movement of electrons is the movement of a charge. Electrons, as you can see in this particular diagram, are loosely bound to the nucleus, whereas the protons and the neutrons are tightly bound to the nucleus. The electrons are always flowing freely in the orbitals of the nucleus. These valence electrons are moving randomly and are not aligned. There is no flow of the electric current in the wires because of their random movement. But as soon as the wires are connected to a battery supply, the electrons, they start aligning themselves, all the electrons in the valence shells, they start combining and aligning themselves in a particular direction, thereby resulting in the flow of the charge, which produces electric current and thereby producing electricity. So it is very important for the electrons to get aligned and move in a particular direction in order to produce the electric current. Substances like metals have lots of free valence electrons. Therefore, they are good conductors of electricity. As soon as they are connected to a battery, the valence electrons and the freely moving electrons, which were randomly moving, they align themselves in a particular direction and they start moving in that direction and thereby producing electricity in the same direction. So we conclude that the flow of electricity is due to the flow of charge, which is due to the flow of electrons. Charge here is denoted by the symbol Q. and current is denoted by the symbol I. Therefore, current I is equal to the rate of flow of charge, that is Q. That is, current I is equal to Q by T, where Q is the symbol denoting the charge and the standard international unit of charge is coulomb. So time is measured in seconds. So we say that current I is equal to coulomb per second, and 1 coulomb per second is equal to 1 ampere. Therefore, we say that ampere is the standard international unit of current. So current is always measured in amperes, which is equal to 1 coulomb per second. So with the help of the diagram shown here, we can see the movement of electrons, thereby producing electrical or the electronic current from the negative to the positive terminal of the battery. The flow of the current is due to the flow of the charge, as we already know. There are so many electrons that are moving. So, what is the work done in moving one charge in 1 second? So, the work done and the efforts made to move one charge from one negative terminal of the battery to the positive terminal is what is known as the potential difference. Potential difference is the work done per unit charge. We denote the potential difference, also known as the electrical potential, as V. So, V is the electrical potential or the potential difference across the battery, which is also known as the amount of work done in moving the charge from one end of the battery to another end, which helps in the glow of the bulb and thus producing electricity. Therefore, we say that V is equal to W upon Q. V is the work done per unit charge. The SI unit of work is joules and that of charge is coulombs. So we say that 1 joules upon 1 coulomb is equal to V, which is equal to voltage. So voltage is denoted by V. The SI unit of voltage is volts. Therefore, we say that 1 volt is equal to work done per unit charge. This is all for today. Next time we will discuss about magnetism. So, goodbye for now. Take care and please don't forget to subscribe my channel.